So, if you're watching this video from your computer, you probably have a keyboard in front of you. If you're like most general regular people, that keyboard might be a membrane rubber dome style keyboard. But if you're a bit of an enthusiast, you might have a mechanical keyboard. Here are some short typing demos. But in the end, these are both keyboards that use mechanical connection on a circuit board to detect when a key is pressed. It doesn't matter if you're using Cherry MX, Rubber Domes, Gatoron, or whatever fancy new switch you have. The vast majority of these keyboards are going to use the same actuation method, closing your circuit on a board through physical contact. Well, how exactly does that work? Well, most modern keyboards are now built around a PCB, or a printed circuit board, which is just one big matrix with diodes for each switch. Now, most modern switches are built similarly to the famous Cherry MX line of switches and have the same basic parts. These switches have metal pins which insert into these metal contacts on the PCB, which are then soldered on from the back. Inside a switch are the same components: the top housing, the stem, the spring, and the bottom housing. On the bottom housing is the metal leaf, which is responsible for the actuation of a switch. Now, this is the main gripe that many have had with these type of switches, which is the reliance of maintaining constant physical contact with the metal leaf, which can cause friction and create unnecessary noise while typing. While this may seem a little negligible to the layman, these enthusiasts will go to every length that they can to create the perfect and idealized typing experience for them. One solution that many have turned to is the application of lubricants to the stem, the housings, and the spring of each individual switch. This is very, very cumbersome and manually engaging to do for every single switch, besides factory looped switches. So a very few amount of people have turned to alternative designs, which include the contactless version. The Hall effect is a physical phenomena that occurs between a current-carrying material and a magnetic field, and has been used to make mechanical switches for many, many years. Nowadays, Wuting historically uses these in their Lecker switches to create contactless switches that actuate using the Hall effect. Now, while I don't have a keyboard from Wuting to show you today, we do have Lecker switches that we can look into. So, the components of the switch itself are actually very simple. Much like an MX style switch, it consists of a top housing, a stem, a spring, and a bottom housing. But unlike an MX style switch, there is no metal leaf on the bottom housing, and there are no metal contacts on the bottom. Rather, the switch has a magnet inside of the stem, which, when pressed down, approach the PCB. Now, being contactless, these Hall effect switches are naturally very smooth, but that's not their only advantage. They can also provide new methods of actuation. While standard mechanical switches like metal leaf switches give only binary on or off inputs, Hall effect switches can provide a spectrum of inputs that allow you to detect how deep you press your switch, or even allow you to set custom actuation points on the fly. While Wuting is a great option that provides these cool features, there is another switch that can do the same.
Optical keyboard switches are similar to a mechanical keyboard, but they instead use light to detect inputs. The stem of the key is blocking a laser, and when you press down on the cap of the key, it pushes the stem down a shaft, allowing the laser to connect with an infrared sensor, detecting a key input. By using light to detect key inputs, it allows it to become immune to most of the things that can cause other keyboards to get worse over time, such as oxidation, wear of metal due to metal-on-metal contact, as well as potential spills on the keyboard. It can also have up to 0.2 millisecond response times due to having a much smaller actuating distance. More specifically, optical switches use passive infrared sensors. Part of Planck's radiation law is that unless an object is at absolute zero, it'll emit some quantity of infrared radiation. Given that, these passive infrared sensors detect infrared radiation using a lens to focus down the radiation onto a pyroelectric sensor, which detects infrared radiation levels. These types of sensors are typically used in motion detectors, which detect when something is moving by seeing the different levels of infrared radiation. For example, if a person walks in front of it, it sees the elevated levels of infrared radiation coming off of their body, and then uses that spike in infrared radiation to tell that there is motion. In comparison, in these optical keyboards, it's used to tell when a key is being pressed or not, as when it's pressed, a laser emitting infrared radiation is exposed, allowing the passive infrared detector to detect it and detect that spike, knowing that someone is pressing the key.
While there are a lot of these cool and interesting switches available, it turns out that the vast majority of mechanical keyboards, even in high-end enthusiast boards, use metal leaf contact switches. Maybe it's just a part of getting these switches to sound their best that's an essential part of the hobby, or maybe it just fits into people's budgets better. It goes to show that some things are better left simple. Thanks a lot to Michael Leung for lending us his optical board and Ihyun Jun for being in charge of the cinematography. And most importantly, thanks to you for watching.
Yay!